Hey everyone, today we are going to be talking about zero force members. Now, zero force members are something you see in problems every once in a while, and I've noticed that it tends to trip up a lot of students early on in the trusses section. So today we're going to go over zero force members, hopefully get rid of some of that confusion and make sense of what zero force members actually are. So a zero force member is a member or a beam in a truss problem that carries zero force with it. And we can tell what members are zero force members just by looking at the problem. Now, every once in a while, the force in a beam may end up being zero just randomly because of how the problem works. That does not necessarily make it a zero force member, or at least the kind that we're talking about right here. So you'll always be able to tell a zero force member if it is, well, let's just look at these cases right here. If, like in this case, it is the only member in a direction, so if we notice we have two members here, both of those are in the x direction. This one member going up is the only member in the y direction for this case. So that would mean that this is a zero force member. Let's look at why that is. So if we were to draw this point down here, our free body diagram for it would look like this. Well, some of the forces in the x, we would have, let's call this force 1, force 2, and force 3. For the sum of the forces in the x for this problem, we would have force 1 minus force 2 equals 0. For the sum of the forces in the y for this problem, we would have F3 and then just equals 0. So that is a quick explanation as to why those are always zero force members. Okay, let's look at this case down here. Whenever you see two members that are just kind of off in space that come to a point, those are zero force members. So let's look in this case right here. We have these two right here are zero force members because if you notice they're just off in space, they don't have anything attached to them. And then same with these down here. So that's a zero force member, that's a zero force member, that is, and so is that. So anytime you see something like this, just off in space, and they don't have anything to attach to them out here, those are both zero force members. Now, as soon as you attach a force to those, say we put a force of 10 pounds going down right there, those would no longer be zero force members. It's actually also the same with this right here. If we put a force there, that would no longer be a zero force member here. Okay. Now let's look at this one right here. Is this a zero force member? Well, unfortunately it's not because we have this force going out here. But what if we erased that? So we get rid of that beam. Now, is it a zero force member? Well, the answer is still no because there is a support there. This support gives another reaction force. That adds another force there, making that not a zero force member. Now, something important to look at is if a force is a zero force member from one side, it is always a zero force member. It doesn't matter what's happening on the other side. Give that as many forces as you want, but if it looks like a zero force member from one side, it is a zero force member. So that would be if we had a case, say like this. Okay, now down here we have all types of forces coming out of this point right here. So it doesn't look like anything is a zero force member from this side. But if we come over to this side, right here, we notice that this one is actually a zero force member, because at this joint right here, there is only one force coming out in this opposite direction of everything else. These are all lined up, this one's not, so that's a zero force member. So you can just make that one go away. And actually, say we got rid of this force over here, and we have something like that. Well, if we're looking at this pin right here, this now becomes a zero force member too. And then if we look at this pin over here, this is a zero force member. So once we know something is a zero force member, we can erase it. And once we erase all those, we now notice, well, this is a zero force member too. So our problem just ends up looking like that. So even though there was tons of stuff happening at this point, from every other point, those were zero force members. So everything through that point just ended up being a zero force member too. Anyway, those are the two basic rules for zero force members that you will see all the time. And also just remember, whenever you see a zero force member, you can erase it off of your problem. Just get rid of it, don't worry about it, pretend like it never existed. And that should simplify things up a bit more for you. Hopefully make the problem look a little bit easier and give you less unknowns, so you need less equations to solve the problem. Anyway, I'll see you guys next time.